The first experiment illustrates the redundancy on the distribution of wrenches required to recover the balance. If the COM is shifted to the left, the robot can only use the feet for balancing, as the unilateral contact at the hand can only be used for pushing. If the COM is shifted to the right, the robot can also use the hands, which allows a larger COM shift in this direction. In this experiment, Toro is lifting a box. The hands are operated in a compliant mode, while the legs are used for balancing. In order to prevent a disturbance of the COM, the legs counteract the forces generated by the hands. The tracking performance of the proposed controller is evaluated in this experiment by commanding a sinusoidal COM trajectory to the robot. The proposed controller improves the tracking performance if feed-forward terms are included, which reduces the difference between the commanded and the real contact wrenches. For this reason, the robot fails if the amplitude is increased to 8 cm and the feed-forward control is deactivated. Balancing on a compliant support surface is a difficult task for a humanoid robot because of the unmodeled dynamics of the support surface. On this type of surface, a balancing controller is essential for stabilizing the robot. The close-up shows that the feet have to constantly move to keep the balance. As soon as the emergency stop is pressed, the mechanical brakes of the joints are engaged and the robot freezes and falls over. In order to allow the robot to lift and move each end effector during the execution, we implemented a state machine that can reconfigure the contact states online. The optimization problem required to compute the wrenches that recover the balance has a constant size, thus it's not necessary to reinitialize the optimization every time the contact configuration is changed. Note that the robot is capable of balancing in a compliant way, even in challenging contact configurations. The next two experiments show the robot balancing on a rocker board, which can be tilted up to an angle of 6 degrees. Even if the COM is manually commanded to a new position, the robot successfully balances on top of the tilting surface. Balancing on one leg is even more difficult because of Toro's small feet, which are only 9.5 centimeters wide and 19 centimeters long. Here, Toro is wearing shoes while balancing on a pile of stones to illustrate the robustness of the controller when the robot is on unstructured terrain.